This question is from machine design for 2 marks. A single block brake with a short shoe and torque capacity of 250 Newton meter is shown. The cylindrical brake drum rotates anti-clockwise at 100 rpm and the coefficient of friction is 0.25. The value of A in mm round off to 1 decimal place such that the maximum actuating force P is 2000 newtons is. So this is a question from design of brakes, and for this numerical answer type question the accepted answer range is 212 to 213. Let's proceed to the solution. It is to be noted that in the given block brake we have a drum, a brake drum, and a shoe which is attached to a lever, and it has a fulcrum here. So let us try to draw the free body diagram separately of the shoe with the lever and the drum. So this is the drum and the direction of rotation of the drum is given as anti-clockwise. So when the drum rotates anti-clockwise, friction develops on the drum towards right, which is exactly opposing the direction of motion of the drum. And since the drum is in contact with the shoe which is attached to the lever, the shoe will exert a reaction force Rn downwards. Okay, now it is also given that the coefficient of friction is mu, which is 0.25. So friction force can be written as mu into reaction force. It is also to be noted that A is the radius of the drum. Now let us come back to the free body diagram of the shoe with the lever. So since the shoe is exerting a reaction force Rn vertically downwards onto the drum also will exert the equal reaction force onto the shoe in the opposite direction Rn. From the shoe point of view, since the drum is rotating in the anti-clockwise direction, friction force on the shoe will be exactly towards left, so that the friction force developed on the drum and friction force developed on the shoe will cancel out each other. It is also given that the actuating force is 2000 newtons, which is extreme at the left. Therefore, actuating forces P is equal to 2000 newton and all other distances are given in the question. Now, it is also given in the question that the braking torque is, or the maximum torque capacity is 250 Newton meter. So that can be taken as the braking torque, which is TB is equal to 250 Newton meter. We know that braking torque can be written as force multiplied by radius. Therefore, TB is equal to force is the friction force multiplied by the radius of the drum, which is A. So since we have TB is equal to 250, we can write and simplify this as F is equal to 250 by A. Next step is we know that F is equal to mu into Rn. So that implies F is equal to 250 by A, which is equal to mu is given as 0.25 into Rn. From this we can write down Rn is equal to 1000 by A. Now let us consider once again the free body diagram of lever with the shoe. Since we have the free body diagram of lever with the shoe, let us impose the condition that moments about point O should be equal to 0. Therefore, it is to be noted that in this particular question, all the anti-clockwise moments are taken as positive and all the clockwise moments are taken as negative. So since we apply the condition that summation of moments about point O is equal to 0, the first force which will introduce the moment will be the braking force or the actuating force, which is 2000 multiplied by perpendicular distance is 2.5 A. That will be equal to the reaction force multiplied by A, which is the perpendicular distance, plus the friction force multiplied by A by 4. So since we have Rn is equal to 1000 by A and friction force F is equal to 250 by A, when we substitute these two corresponding values, this equation turns out into this way. Now in this equation, it is to be noted that we have the only unknown as A. So simplifying this equation, we get A is equal to 212.5 mm.